In this video, I'm going to talk about various kinds of type conversion in C#. We have implicit type conversion, explicit type conversion, which is also called casting, and we also have conversion between non-compatible types. Here is an example of implicit type conversion. A byte, as you know, takes only 1 byte of memory, and an integer takes 4 bytes. So we can easily copy a byte to an integer. What happens at runtime is, let's take a look at this slide. So here's the binary representation of our B variable here. So 1 is represented as 7 bits of 0 and 1 bit of 1. When we copy a byte to an integer, what the runtime does is it prefixes that value with a bunch of zeros to fill the 4 bytes. So there is no data loss. In situations like that, when the compiler is 100% sure that the types are compatible and no data loss will happen, values can be converted to a different type implicitly. Here's another example of implicit type conversion. So we have an integer, set it to 1, and we copy that to a float. Again, in this example, no data loss will happen. But let's take a look at this one. Here we have declared an integer, and we're trying to copy that to a byte. An integer is 4 bytes. So when we convert that to a byte, 3 bytes out of 4 bytes will be gone. And there is a chance for data loss. Now, data loss doesn't always happen. It only happens if the value we stored in the integer is beyond the capacity of a byte. In this example, 1 can be stored in a byte, so no data loss will happen. But if we had, let's say, 300 here, we cannot store 300 in a byte. So as a result of that conversion, data will be lost. When the compiler knows that there is a chance for data loss, it doesn't allow implicit type conversion. And you need to explicitly tell the compiler that you're aware of the data loss and you still want to go ahead with the conversion. In situations like that, what we do is we prefix the variable with the target type. So here, I'm trying to convert I to a byte. This is what we call as casting. Here is another example. So we have a float set to 1.0. And if we try to convert that to an integer, the compiler would complain. I will show you that later in the coding demo. So we need to tell the compiler that we are aware of the data loss and we still want to convert f, which is a float, to an integer. So we cast it, like here. Sometimes we are working with types that are not compatible, but you still need to convert them. For example, we might have a number represented as a string, as you see here, and we need to convert it to an integer. In situations like that, because string and int are not compatible, we cannot use explicit casting. So we need a different mechanism for converting a string to a number. In situations like that, we need to use the convert class or use the parse method. So convert class is part of .NET Framework and is defined in the system namespace. It has a bunch of methods for converting various types to other types, and they all start with 2. In this case, we're trying to convert s, which is a string, to an int32. Int32, as you know, is a .NET Framework type, which maps to a C# integer type. Remember, a byte is 1 byte, a short is 2 bytes, an integer is 4 bytes, and a long is 8 bytes. You probably know that each byte has 8 bits. So an integer which has 4 bytes times 8 bits ends up being 32 bits. That's why it's called 2 int32. And int16, which represents 16 bits, equals to short, which is 2 bytes. We also have this parse method here. All the primitive types that I explained in the last lecture, like integer, long, float, boolean, they all have this parse method. And the parse method takes a string and tries to convert that to the target type, in this case an integer. Here are some of the methods that you can find in the convert class. To byte, which converts the given value to a byte. To int16, to convert the given value to a short. To int32, to convert the given value to an integer. And to int64, to convert the given value to a long. Okay, enough theory, let's jump into code and see all this concept in action.